In this video, we will address one question: how are tsunamis formed? How are these anomalous waves generated? What triggers them? Welcome to your daily dose of enlightenment. You've landed on Knowledge Planet, where curiosity thrives and the enigmatic is revealed daily. We delve into a variety of topics to amaze you. Now let's get back to our intriguing subject. Essentially, there are 4 triggering mechanisms for a tsunami. I'll list them quickly and then we'll examine each one in detail. The first and primary mechanism is the activation of submarine faults, which is practically an underwater earthquake. The movement of a fault generates seismic waves and releases energy in the form of seismic waves and flaws that occur after the earthquake. We'll see later why a tsunami is created. The second mechanism is a landslide, where a landslide falls into the sea. The third mechanism is a submarine volcanic eruption. The fourth mechanism is the least frequent, which would be the fall of a meteorite or asteroid into the sea. Now let's look at each one in detail, but a fundamental concept that unites these 4 mechanisms is that to generate a tsunami, to move water, a whole column of water requires a movement of a large mass of rock. So how do we move these large masses of rock? If you think about it, faults move, the Earth's crust moves. These large masses of rock fall due to gravity during landslides. Volcanic eruptions are nothing but a movement of rocks, an expulsion of material which still involves a movement, and with a meteorite or asteroid it's obviously a movement, a displacement that generates a corresponding movement of water. So guys, this is the key element. If someone asks you how a tsunami is triggered, the general answer would be a movement of rocks. Of course, there are various cases which we'll now delve into. Let's start with the first triggering mechanism, the activation of a fault, which is definitely the most frequent trigger mode. In fact, consider that 90% of tsunamis in planetary history are due to the activation of a fault. What does the activation of a fault involve? Surely many of you already know, but let's briefly repeat it. Tectonic stresses, the theory of tectonic plates, etc., they move, and for various reasons stresses accumulate, that is, efforts. At a certain point, the Earth's crust can't hold anymore and breaks in a fragile manner, or deforms in a fragile manner. That is, there is a movement, practically. This fracture, this crack, is a huge crack that can affect vast regions, tens of kilometers, even hundreds of kilometers if you want. It's a fracture with a relative movement of one of the 2 plates which can move up or down relative to the other. So if I apply, for example, a compressive force, one of these 2 plates tends to rise. This is a phase. And to be more precise, if it moves like this, it's called a reverse fault. Otherwise, if there is a stress pulling instead of pushing, then these 2 plates will move away from each other in this way, according to an inclined plane. In both cases, there is a release of seismic waves and an earthquake is created. However, the point is that when this huge underwater slab of land, this practically marine bottom, moves suddenly, as I said earlier jokingly, there's the crack, and the crack happens really quickly, in an instant. This movement, which is actually called fault slip, can range from a few millimeters to several centimeters or even several meters. So, imagine the seabed suddenly, several kilometers deep due to this fault, creating a 5-meter step. This step practically tends to push the entire column of water, which may be 2 kilometers high, upwards. In the case of a reverse fault, this movement is the spark that will then create a series of anomalous tsunami waves that will reach the coasts, unfortunately. What happens during the tsunami's journey to the coasts, we'll see at the end after talking about the 4 triggering mechanisms. It's actually very interesting, it changes a lot. The motion of the water, how it occurs, well, I'd say the first thing to have in mind is that the movement of these waves, this wave motion, is very different if we're talking about open sea or near the coast. In open sea, if we have a little stick and tsunamis pass, actually, we wouldn't even notice it very hardly because the wave height is very small, and the wavelength, precisely the trough, let's say, is very long, so big ships, cruise ships, etc., might not notice it. Do you know how fast a tsunami travels in open sea? We're talking about over 500 kilometers per hour, between 500 and 1,000 kilometers per hour, practically the speed of a commercial airplane. That's insane. What happens when the tsunami reaches near the coast, where the seabed is shallower? In this case, the water will collide with much more force on the seabed. There's friction, and because of other factors as well. What happens is that the propagation speed of the tsunami decreases because all the energy that the tsunami carries with it can't go away just like that. Obviously, it can't disappear. It's the principle of conservation of energy. What happens is that the height of the tsunami increases as we move towards the coast. the seabed gets lower, and our tsunami grows, thus favoring the formation of a real wall of water preceded by a phenomenon, the gradual withdrawal of water. This withdrawal of water, and I ask you to pay attention because it's very important, especially in cases of, let's say, risks. If we were to find ourselves in front of a tsunami phenomenon, hopefully not, but it's better to know before the arrival of the first wave. There's a withdrawal of water, and this is practically the only real warning in advance of a tsunami. The withdrawal happens a few minutes before, more or less about 5 minutes before the arrival of the wave. So, when we're at the beach, everything is fine, sunbathing, etc. Suddenly we see that the sea is visibly and sharply retreating for tens of meters. Even leaving the boats on the seabed, we're most likely facing an anomalous situation which could be a tsunami. So, at that moment we shouldn't think about anything else but simply heading to the highest and nearest area. So, the substantial difference in the motion of a tsunami in open sea is small. It goes like a jet near the coast. Its speed decreases drastically and its size increases. A little aside, surely someone will ask, what's the difference with normal waves? Normal waves are usually caused by the wind and only affect the upper portion of the water. That is, the moving water is not the entire column of water, as in the case of tsunamis. Tsunamis are caused by a displacement of a huge amount of water, as we've seen in the 4 triggering mechanisms. With that said, guys, thank you so much for watching this video until the end. We'll see you in the next video, right here on Knowledge Planet, the power of knowledge. Consider us more than just a channel. We're a growing community, a family of knowledge seekers. We're on a mission, inviting you to join our growing family. We need you. Subscribe, become part of our community, share your thoughts, interact with us, a like or even dislike all count. Stay tuned, stay curious, and together we'll continue to explore the vast expanse of Knowledge Planet. Don't forget to watch the previous episodes and stay tuned for the upcoming ones. And if you're not subscribed to the channel, what are you waiting for? Subscribe now. And one more thing, that little bell icon, it's your ticket to never missing a beat. Click it, and you'll be the first to know when fresh content hits the airwaves. Goodbye.